Okay, so lesson 43 is about least common multiple, which you've heard when it comes to numbers. Do you remember how to find the least common multiple between, let's say, 8, 35, and 24? How would you find the least common multiple?
35.
Because I want to make it difficult.
Maybe that's too hard.
How do you do it? Do you remember how?
Yes.
How?
Try to find them all the same ones, same number.
Do you do prime factorization, right? And how do you do prime factorization, sir? In all the way to the back.
You gotta put the number, I think, in the right side that can divide all three of them.
Or just only 2 or 1.
It doesn't have to be all three of them. You have to get all three to a number 1 in the bottom. So in this case,
2.
2.
4,
And that only
4,
works.
5,
This one stays the same.
12. And then 4 and 2 again.
No.
2. You can't put 4 because 4 is not a prime number.
2,
2.
35, and 6, and 2 again. And 1,
So this one's done.
35, 3, and then 3.
And 3.
1, 35,
No.
Yes.
and then 1.
And then 5.
And then
And
5.
then 5.
1, 7, 1.
And then
7, 1.
Okay.
1.
Now I have them all down to 1. What do I do now?
2 times 2 times 2 times 3 times
Very good. So it would be 8 times 3, which is 24.
No, times 6.
24
No, it's 8 times 6.
times 35.
34.
And 25 times 35 is, how much is 25? 35 times 24.
35 times 24. 840.
840. That would be your least common multiple between 8, 35, and 24. Okay? Now, it doesn't matter how large the numbers are. If you use prime factorization, you will always get to the least common multiple. Now, that's with numbers. What happens when we have letters? For example, 15a squared b, 10a b cubed. Anybody have any ideas?
I think I have. Oh yeah, 5 will be the common denominator of the both numbers, and if the common denominator of the variables would be A and B.
I'm going to stop you right there. Yes, you are correct in the factor side, but we're not looking for a common factor. We're looking for the least common multiple. So,
First, do it with the numbers.
with the common factor, remember?
2ab squared.
No, that's a factor. Let's see if we can do it this way, shall we? We've got 15a squared b and 10ab.
It's 30a squared b3, miss.
Let's see.
It's 30a squared b3.
And there you go. So let's try the 5, and we've got 3a squared b, and we've got 2 ab cubed, and then we've got a 3a squared b, and we've got 2 ab cubed, right?
And then 2.
Huh?
Then 2.
2. So that gives us a squared b and ab cubed.
And
Now,
that will be 8 cubed b.
Means now you can do 8.
8 cubed b to the power 4.
now we could be b cubed.
No, 8b.
It's got to be b first.
b3. B,
No,
b cubed.
No, A2, and then A, B.
It's got to be b first because you got to get rid of this b. You can't divide this one by b cubed, so it's got to be b.
B cubed.
A
So
squared.
that,
A squared.
why don't we put ab?
A,
So we've got a
comma,
And b.
B2,
b
B
squared, 2,
and b squared. And now we've got a
B,
and b squared, right? Because this would be 1, and this would be b squared, and now a 1. Now we multiply all of these together, and we've got
30.
15 30, a squared, b
Q.
cubed. And that is your least common multiple.
So you gotta do all that.
No, there's an easier way. I'm gonna do another one and let's see if you can find the pattern. Okay?
Mister, don't erase that one.
I'm not gonna erase it. Okay. Let's see if you can find the pattern for this one. 4x squared, 6x cubed m.
Okay.
You ready?
Two,
Okay, 2,
and then 2x squared,
2x squared,
comma, 3x apart 3m.
3x cubed m.
And then 2 again,
And then 2 again,
x squared,
x squared,
comma,
4x
3x,
cubed.
3m.
m.
And then 3,
3,
x squared,
4x cubed.
comma, x apart 3m.
m.
And
Okay.
then x,
Now we can stick x squared in. Because we have to get to a 1, remember?
1, comma, x, m.
And now we can just
xm,
xm,
1,
1, and 1.
Is it 4? Is it 24 x cubed?
Let's see.
M?
2 times 2, 4. Times 3, 12. X cubed,
m.
m.
Oh yeah.
That is your least common multiple.
That's easy.
Does it have to be the least?
Yes, it has to be the least. The least meaning there's other common multiples like x to the 5, m, 24. But there's something that is lower than that.
Do you guys multiply?
Is there a pattern that you notice?
Yes.
It's just
What's the
choose that,
pattern?
choose that biggest exponent.
Choose the biggest exponent and include all of them. So over here, this one doesn't have an m, but that one does, so that one you have to include. The biggest exponent is the x to the 3. That one goes in there. And then you find the least common multiple for the numbers, and you're good to go. So, now that you've discovered that pattern, let me give you another one, and let's see if we can do it without the table.
Okay, without the table.
Without the table.
But we need to use the table, right?
You don't need to use the table if you can see it just like that.
Oh, really?
Really?
Yes. Should know this.
So, what would be the least common multiple here?
2.
No, that's a factor. The least common multiple between 12 and 14.
45.
No.
2 is a factor, not a multiple.
It's
1.
20. No, it's not 20.
84. X cubed. A to the power 4.
Let's ignore the numbers for a second, and let's just focus on the variables. What would the variables be? What would include everyone?
X cubed. A.
And to the power of 4.
Okay, so we've got the variables part. That's the easiest part, right? What if this one didn't have an A? Would this still be
No.
the least common multiple? Yes, it would be, because it's got to include everyone, right? And you take the one with the highest exponent, so that's good.
84.
Now, if you can't figure out the numbers, then you would have to do a table for that.
84.
But you say it's 84, so let's see, 12,
100.
14, 2, 6, 7, 7,
84.
1, 6, 3, and 2, right? This is 14 times
42 times
84?
2.
84.
Yeah.
So, do you have to do the big table every time?
No.
No, you just choose the ones that have the highest exponent in the variables. The
And you want
numbers,
to do the
if
table?
you want to do the table, because you can't, then by all means, but it's easier doing just the numbers than it is doing with the letters, right?
Yes.
We good?
Yes.
You understand least common multiple?
Yes.
Okay.
Will you do the table?